So the next unit we wanted to cover is coming under the basic unit 1, an overview. So this deals with types and manufacturing methods. What are the types? First of all, let us go through the definition of geosynthetics itself. As per ASTM, we have the definition. It's a planar product manufactured from polymeric material used with the soil. Actually, there is a typing mistake. Used with the soil, rock, earth, or other geotechnical engineering material as an integral part of human-made project or man-made project, structure or system. Mind you, this is very important. It could be a structure, it could be a system, it could be a system, it could be a structure, and that is what we are going to go through systematically. So in the beginning, we thought that there are certain standard types. Let us say the first class of materials we said is going to be geotextiles, but geotextiles is a class of materials. Actually, we call as a generic classification. That means we are not making a product from a company, we are talking of generic product now. So by generic name is geotextiles, but we find later that okay, the geotextiles are not one material. Probably it will cover 3 types. I mentioned 2 only here: the woven geotextiles and non-woven geotextiles. Then we have the second variety. We can call them as geogrids, second class of materials. Why they have come up, we'll see as we move further. Then we have the third class of materials, which is called as geomembranes. And then we have the fourth class of materials, which are called as geocomposites. So these are 4 major generic groups, you can say that. Under each one, there are varieties which are going to go through systematically. And if you want to look at the color now, naturally they are different in color. They are looking at the look now. Some of them are grids now, some of them are meshes only, some of them are rough surface now, made of jute and made of many kinds of things, maybe pipe also. So we have a range of products which are going to be there, more detailed than the basic class. This is basic class. So there are 4 classes of geosynthetics now, generic classes or generic groups: geotextiles, geogrids, geomembranes, and geocomposites. So when you start getting into this now, what we are going to look at is, we are going to look at, as already said, onto the types and manufacturing methods now. So for this now, we come to initially, what are the common polymers which are used for these purposes? And then what are the systems of producing geotextiles, you can say, because we have to first produce a fiber or filament, and then from that, our geotextiles will come in. Then we have geonets and geogrids. We have membranes, geomembranes. Then we also have geostraps, geocells, metallic reinforcement, then geocomposites, and natural geotextiles. So even if you see that now, just in the previous slide, I said there are only 4 classes: geotextiles and geogrids and geomembranes and geocomposites. But now I have already said there are more of them now. In each one, we are going to have more varieties also. So for example, we can think of having something like 20 varieties of these materials. That means 20 generic materials now. But then sometimes in a given product now, the companies can make slightly difference also. So that's why we are giving a general classification only. For example, geogrids also, there are two major classifications, and each classification there are going to be 2 sub-classifications. So we'll see that now. It's not confusing. When you see them in actual lesson, we'll be able to follow that. So what is it we are going to look at is, we are going to look at each one of them now, how they are made and what is the advantage of that, or what is the difficulty with this now. I think today we will start with polymers only. What are the common polymers? So that is what we are going to do. So we are going to look at what are the polymers which are going to use on the material to manufacture the materials. So the polymers which are going to use are polypropylene, high density polyethylene, HDPE. Mind you, by the way, polypropylene is also simplified abbreviation is going to be PP. We call as PP means polypropylene. HDPE means high density polyethylene, and polyester we also call as PET, PET, and fiberglass or glass fiber, and PVC, polyvinyl chloride, synthetic rubber, natural fibers, jute and coir. Now, do we make all of them with all these things? No. Certain types of products are made with certain of these polymers now. So let us see what exactly we are going to do. So if you just try to not confuse you really, but let us see what is the typical formulation. So when we say that there is a plastic bucket, maybe the plastic bucket is made of polypropylene, let us say. So the polypropylene bucket is not exactly same thing as a polypropylene geotextile or a geogrid actually. So we should remember that now. So there are certain characteristics which are going to be there. For example, if you think of a PVC product in our subject now, so PVC means we are not going to use a pure PVC. We are going to use what we call as processed PVC, processed size of PVC. And resin means the basic material. That means in each case it may be polyethylene or PP. So when you talk of PVC now, the PVC which are normally used for lining canals and ponds will only have 30-40% of basic resin. There is something called filler, 20 to 30%. There is carbon black to ensure that it's not affected by sun rays. So it's 5 to 10%. Then other additives to make it workable and to able to manufacture, to make sheets and things like that, another additive is going to be 0.5 to 1. To make it flexible, we need actually another 25-30%. So you see that now the basic PVC we use in making membranes today is only 30-40. Still we call PVC, but we should not call, we may call it as a liner grade. Membrane grade PVC will have all these kind of components. If you think of unplastic material, naturally you can see this is 70 to 85% pure resin, and then other components are much less now. Then if you think of polyester, let us say here, very important component now, polyester PET, as I said already, 96 to 98% is resin. There is no filler. Carbon black could be 2 to 3%, and additives could be 0.5 to 1. And we'll come back to this. Then we go to polyethylene and polypropylene. Again, polyethylene PE is 95 to 98%. And then, of course, the carbon black is there, additive is there, and things like this. Now, polypropylene PP 85 to 96%. So when we say polypropylene geogrid made by one company, geotextile made by one company, it may be using polypropylene of, let's say, 85% resin. Some other company may be using with 90% resin. So it's not exactly the same. It is similar, actually. That is what you have to remember now. Another important chemical polymer we are going to use is polyamide. Typical material is actually nylon. It's called PA. And we will see why we are going to use it. Its use is very limited. It's very expensive. That's why it is limited. And 96 to 98% is basic resin. And additives are very small in content. Now, two things which are going to be coming out is, there's always a competition between PP and polyester. At one point, let us say when we started work now, till about 15 years back, PET was a bit expensive and PP was not expensive. Okay, today the other way around actually. So ultimately, the selection of your product now depends on the cost. After all, it depends on the cost of the raw material. Raw material is, let's say, PP or polyester. Now, if the cost of one material is going up, naturally the product line also is going to go up now. That's what you have to remember. One thing is, it's always going to be cost based, because the polymer cost we don't determine. Reliance, let's say, determines this now. We buy polyester PP from them. Naturally, they have to make it to our requirement. I will tell you what's the requirement in the next slides. The other requirement which you are going to have it is, you remember that there's something carbon black pigment now. So what is the use of this now? They are going to ensure that our geotextiles which are exposed, geosynthetics are exposed, are not subjected to ultraviolet rays. So that's why carbon black is going to be required. So we'll see that also as we keep going further. Okay, then there are other materials called polystyrene, that is called foam material. Okay, what we call as a thermocol actually. And then CSPE, EPDM are actually products which are there for making synthetic, you can say, rubber. So today we don't use much of them. We use essentially HDPE, high density polyethylene, for making membranes, or PVC. We don't use them, but they are in the list actually. The other thing is that now, also the basic properties of the polymers now. What are the basic properties which you are going to look for? For example, I will look at simplest thing, the specific gravity of the material. So polyethylene actually, we find that high density polyethylene, HDPE, specific gravity is 0.96. PP, polypropylene, has got specific gravity of 0.91. Okay, polyester on the other hand has got a specific gravity of 1.22 or 1.3, depending upon what we are going to look at. And of course, nylon, that is the PA, has got 1.14. Now, how does it make any difference to us now? When you make a product with polyester, you want to do some underwater work. That means you want to dip this geosynthetic in water. Naturally, this will automatically keep settling. Whereas this is going to naturally float in water now. So this we have to remember now. During construction, we have to see that now. Also, when the density specific gravity is less now, That means for a given weight of material or given mass of material, we are going to get more area. Remember this now, isn't it? So here a given square meter of area will require more of polyester by weight. That is, the quantity of the polyester is going to be more. That means that's why they are going to be slightly more expensive. Okay. In the same way, you take a look at the effect of heat, particularly the melting point of polyethylene is 110 to 140 degrees Celsius. PP is 160 to 170, and then polyester is going to be 250 to 290. So what is it we are going to prefer now? Our preference, let us say, to use in thermal conditions. Let us say if you want to use in payments, flexible payments now, along with the top material like bituminous concrete or such less bituminous macadam, naturally, you want to include them in this, probably we'll prefer polyester. Or at best, we'll also prefer PP, but then not polyethylene because that is going to melt. So at the laying temperature bitumen now, bitumen mix now, this is going to melt. So we can't have it now. So here it is definitely higher melting point. So naturally, the choice of the polymer depends upon how we are going to use it also. And if you really try to see this now, one important development we can also think of it is, what is the strength of the polyester? So we find that the strength, we don't worry about units, I'll come back to units separately. But then, you know, this breaking tenacity, that means breaking strength now, for polyethylene, we don't have at all. What do you mean by this actually? Why it is silent? It's not that data is not available. It means that actually, we cannot get actually in the filament form polyethylene. Polypropylene is very easy to make it like that. So that is another important point we have to make it now. Okay, so we can go through these kind of tables in course of time. But one other important thing we have to remember, of course, is what is the filament? I'll come back to this slide again. I will tell you later what is linear and what is text. We'll watch this next time. So then all these are subjected to ultraviolet light, temperature, oxygen, humidity, and then airborne agents like chemical agents and biological agents. So whenever we are going to expose the material, yes, during construction, they are exposed to, for weeks, somebody may dump on the ground and then only use it in a wall or some other kind of case now. So during exposure, what is going to happen now? During storage, what is going to happen now? And during performance, if they are going to expose, what is going to happen now? So for this now, we will have to add some chemicals, all the additives, all the fillers we have to add to make it actually durable. That is going to be important point. If you try to look at that now, suppose photo degradation now. So PET is material, and here there is no damage. Here there is a damage is very high actually. So if you think of oxidation, naturally damage is high and less now. Whereas chemical resistance is different now. So what is it you find is now degradation is going to be possible. So we have to add some chemicals to this now. We'll see later at a stage what are the kind of chemicals we are going to use. But more importantly, we require actually a certain grade of molecular weight of let us say if you are using polyester, we require a certain molecular weight. The molecular weights which are going to look for is something like 20,000 more. If the polymer has got lesser molecular weight, it's not going to be suitable for us. We'll talk on this later also. Towards the end of this class, actually, this topic, we'll talk what is required to be done. So there are things like molecular weight. There are things like hydroxyl ends. These two are very important. So the polyethylene we are going to use, or the polyester we are going to use for normal shirts or pants or any other tub or something like that now, are different from the polyester which are going to use for geosynthetics now, because they are special grade polymers. And after the grade, naturally, there are additives to make it durable, to make it performance oriented, to make it the characteristic which we require in terms of strength, in terms of friction, and many things now. So we'll just spend 2 more minutes on this now. So once you got this, we already seen the melting point of the systems now. So look at a system here. It's called extruder. In the extruder, we got actually, what is it we got now? There is a hopper now. So in the extruder now, we are going to place this polymer now. For example, looking at the PET, that is polyester, it comes in chips form. These are like almost sugar granules. So they come in a bag now. So before we start making anything out of it now, we have to add all these chemical additives which we already said actually. So we get it mixed first of all. That means we want to make a particular geocentric fiber. Naturally, we are going to already get it mixed earlier in some other plant, get the raw material of polyester or PP or whatever it is, and then add the necessary chemicals, mix them thoroughly, and bring these small chips into this site. So once you do that now, you put it in hopper now. And once it is falling down now, you heat it continuously. And it's got a screwdriver system, exactly like your juice wala makes it. You have the pineapple or whatever pieces you want to make now, and then you crush it through this, and then it comes out now. Okay, so it's called screwdriver system. So when it is being pushed, actually, it's also being heated actually, heated to the required melting point now. So after that, now it is passing through these holes. This is called extruder or spinneret. Extruder or spinneret. What do you mean that now? Again, I'm showing you another way of looking at it now. Here we got the hopper now, is the screwdriver system, and then it's also heated simultaneously. Then we got actually different extrusion discs or dies, we can call it now. What is it now? It's exactly like the way you make bhujia. So the batter is made now, you press it down actually. So here also you're pressing it down. So all these filaments will keep coming out continuously because continuous process now. That means the polymer chips are being placed here and then continuous heated now and then being pushed out through these holes actually. So like we have different size of bhujia or say whatever it is now. So naturally there are even noodles, whatever you make now, it all depends upon the kind of small holes we are going to have. And they are coming out because they are pressurized to come out actually, either in the horizontal direction or the vertical direction now. So when it comes out, actually important for us, I've seen a factory long ago called Petrophils in Ahmedabad itself now. As it comes out, you can touch it also because it's coming out at the temperature of melting point 140 degrees, let us say. As it comes out, it's air cooled now. You can just touch it. It's really hot, slightly hot or warm, you can say. And then you can break it also. Now, what do you mean by this now? What is coming out is called filament. It's called continuous filament now. It's coming as a continuous flow, you can say that. So when that continuous flow is coming now, so what is it you find? You want to expand it in a X-con microscope view, so it will have a diameter. It will have a diameter. And then number of them you can put together and twist it and then make actually what we call as a multi-filament. So here is a monofilament, that means single one is there, is multi-filament now. So we can make things actually using this. So this multi-filament system is what we call as yarn. Okay, this is single filament only. Number of them put together are called yarns now. So filament is a single piece. Multi-filament means number of them are there to get put together now. So that is what we are going to look at as we go further now. So what are the lessons we learned now? We'll also come back to denier and text now. So when you are continuously pushing, what is it we are trying to do? So when you talk of these filaments now, I described here, denier is equivalent to the grams per 9,000 meters of the filament. That means you allow this filament to continuously come out by the extruder or spinneret. So 9 kilometers length of this is called denier. Obviously, it's very, very light material. The denier we have normally using are going to be about 7 to 10 at best, 7 to 12. That means it's going to weigh just 12 grams. Okay, for 9,000 meters. So you can see how fine it is now. And the higher the denier, the heavier the fabric. Obviously, if it is higher, that means 10 grams, 10 denier means it's a heavier fabric. And lighter than that is going to be there. So text means actually the weight in grams per 1,000 meters, 1 kilometer only. So naturally, TX text actually is denier divided by 9 or 1 kilometer length of material. Weight of the 1 kilometer length of material is called a text. That's by definition now. That is what we are finding here actually. You can see this now, gram per denier actually. So that is the unit for that because it's such a small one now. So what is it we are going to look at now? We are going to look at these kinds of resistance now. So what is it we said? We have got continuous filament. And then as it is coming out, I said one can break it very easily. Now how to get the strength out of this now? You have to pull it along the axial direction. When you are pulling along axial direction, even normal fibers which are used for cotton and things also are pulled. That's called drawing. But that is just rearranging only to get more friction, things like this, to make a yarn. Or a thread, you can call it. But in our case now, it is being pulled in the axial direction. And that means now the molecules of the polymer are oriented in the axial direction now. Earlier, they were crisscross, they were randomly oriented. Now they are coming actually into a shape of longitudinal direction. And by that process now, because we orientated them now, the strength increases by 10 to 100 times. That's why I said when you just take out of the extruder now, you can just feel it and then it will also get broken very easily. But once you are pulling along at a given temperature, naturally, they are going to be becoming stronger and stronger now. Okay. Now, from this, I said we can make now, what we can make now? We can make a product actually. We can make a yarn out of number of them now. So that is one way of making a yarn, which is used to make tomorrow, like our handloom system, a geotextile. Now what happens is, if you want to make it like that now, there is a process of making geotextile out of it from that yarn now. But our country doesn't have all the facilities to do that now. At least manufacturers know. What they will do is they will cut into pieces. The yarn is actually coming out regularly. You cut into pieces of about 7 centimeters. That is called a staple fiber. Okay, and the staple fiber now means is very typically similar to cotton now. Cotton has got also fibers, small pieces, but they are varying diameter, varying length, and varying you can say shapes also. Okay, so this is somewhat similar to that now. So we'll use it for certain purpose. We'll see that also later, and that is one thing is there. So all along we're trying to say that the extrusion is happening actually in a circular hole. Very rarely it can be triangular hole also. So the filament is going to be triangular in shape, but it's not always common. On the other hand, now we have a second variety. We call it as a slit film or tape. We'll discuss when we go through the geomembranes. I will tell you more about this. So we'll just skip that. When you see the product, I will tell you what more about that. So spun bonded is a word which I are going to use tomorrow. That means when you go through the process of making geotextiles, wherein right from polymer chips to the product we are going to get in one single factory. It is not that somebody produces the filament and then somebody produces yarn and somebody produces the geotextile, the weaving system. Here, everything is done at one level, in one factory. It's a huge investment. We'll see that now. So yarn, I mentioned already, a number of filaments, multi-filament yarn actually is what we call. And then it's also twisted slightly so that it becomes like what we call a thread is actually yarn. Okay, so denier explained to you, text explained to you. So these are things which you should remember very clearly. Okay, so we'll stop for today. In the next class, we'll see what is geotextiles, and we should remember these principles now. So remember this, you note them down now. You should be able to understand, remember what exactly is there. If you want explanation for that, you can see the videos which are done earlier also. Okay, earlier means the agri videos which are there, and some of these are explained there also. But point is that these are basic, you can say, terms which are important for us as we go further into subject. Okay, I think we'll close for today unless we have some doubts at this stage.
Sir, in the definition of geosynthetics, there was a term system at the very end, structure and system. So
Yeah.
what does this actually mean, system?
I'll tell you one thing is there. We can construct a, let us say, a retaining wall, as I told you, using the soil and a geosynthetic. Okay, that is the total structure now. Instead of a normal
Yes.
retaining wall, instead of a gravity retaining wall or reinforced concrete retaining wall, we are going to build a retaining wall using just soil and geosynthetic. So that is a structure. Okay. On the other hand, I got a dam. I got an Ethan Rockville dam. Okay. In that, there's a filter now. So in the dam as a structure now, the filter of sand and gravel and all is being replaced by a geotextile. So that is part of a system.
Okay.
Okay. So
Understood.
it
Yeah.
will be one piece, just like replacing certain thing with this only. So replacing a certain natural material or synthetic material and doing this now. And also we find that we have different combinations which are going to use it now. It is part of a structure as such now, in which it is only doing one function or one activity, let us say. We'll define what is function as we go further now. There are some basic functions and there are some applications now. Okay, I'm happy you raised this issue. So two things are going to come out now. It is an integral part of the structure. See, till now, the structures are building are made with cement and then aggregate and sand and things like this, or some other chemicals added to this now, or steel, either reinforcement or a sheet or something like that now. So today, we can make structures without using all these, let's say, steel and cement, using just the soil as a construction material and geosynthetics as a system. Okay, that is what we're going to discuss in great detail actually. That is one of the important part of, that is what we call as soil reinforcement for many purposes, improving bearing capacity, constructing walls, constructing, say, slopes. All of them are going to be the challenges which are going to face and which we have designs actually which are available today and a lot of experiences which I'll show you. Okay?
Okay. Thank you, sir.
Anyone else? Any other doubts? So please do recap these definitions very clearly because we'll use them quite common actually. There are some more another 4 or 5 terms which you have to be familiar with because we'll use in these terms as we do design also. As you specify them also, as you test them also, these terms become very important. Okay, that's what I said in the beginning itself. It's a technology. We should know the raw material. We should know the process by which we are making geosynthetics now, And from that, after this next unit 1.3, we'll talk of what are the properties that are going to come out for advantage by this process of manufacture. And once you understand those properties, naturally they are giving the functions, what it will perform. And then naturally, if you know the performance criteria, naturally we can make the structures, like I said, walls or improvement foundations and things like that, we can do it. So it is a from concept to actual application we are going to go through in a very stepwise fashion. Okay. Thank you then. We'll call it a day. We'll meet again Monday. Bye then. Namaskar.